This is Group 23. I'm Zhou Sijie, and my partner Zhou Ruoyu will introduce some information and technology we have learned of V2V in this presentation. Here, we will introduce 5 parts of the V2V. Firstly, I would like to talk about what is V2V. Vehicle-to-vehicle communication is a technology that allows vehicles to exchange information directly between each other via wireless communication technology. Information includes the location, speed direction, traffic conditions, and so on. There are 2 reasons we choose this topic. The first one is V2V is a code of Intelligent Transportation System and IVTS. What's more, as an emerging technology, V2V holds great opportunities and faces many challenges in the 5G and the future 6G area. Since its applications are still in the developmental stage, we have fewer opportunities to learn about it or come into direct contact with it in our daily lives. According to the relations between V2V and V2X, first, I would like to introduce the concept of V2X. There are 4 components of V2X, respectively V2V, V2I, V2P, and V2N. V2V means vehicle to vehicle. Vehicles exchange information directly with each other. And V2I means vehicle to infrastructure. Vehicles interact with data from traffic infrastructure to optimize traffic management. V2P is vehicle to pedestrian. Vehicles share information with pedestrians to improve pedestrian safety. And lastly, V2N is actually vehicle to network. Vehicles communicate with cloud-based servers via secure networks such as 4G and 5G for wide area traffic information. Among the above 4 modes, V2V is actually one of the core components of V2X, focusing mainly on direct communication between vehicles. Now, we will introduce the system framework and more protocols of V2V.
Okay, first let's introduce the VNet system. VNet is Vertical Ad Hoc Network. It's a mobile communication technology that uses mobile vehicles and traffic facilities as nodes to form a mobile network using the wireless communication technology. When a vehicle joins the network, will become a wireless node or wireless router. The wireless network allows cars communicate with cars that are 100 to 300 meters away from each other. When a vehicle leaves the signal range, it will leave the network. Also, other vehicles can join link with each other. Under these machines, the network actually is a dynamic network and allow direct communication without a base station. At present, the extinct VNet message propagation machine can be divided into 3 categories: the location-based, the topology-based, and the broadcast-based. For location-based message machines, nodes use their location to communicate with each other. They send data to the surrounding nodes and then circularize information to select the best place. And nodes don't require global information in the network. The topology-based message machine mainly uses the link information to select the message path when making routing protocol. It's relatively simple. It can also be subdivided into active and the reactive one. And the last one, the broadcast routing protocol, is very simple. It just transmits packets to all nodes within the communication range, which is simple and fast, but the higher danger of the information leakage may exist. For now, the VNet system is mainly used in the areas such as collision prevention, assisted driving, and the traffic flow optimization. Next is the network protocol part. In V2V, there are mainly 2 protocols. the IEEE 802.11p, and the LTE-V2X, also the 5G NR-V2X. For the IEEE 802.11p, its basic information is shown on the PowerPoint. It uses the ITS dedicated band based on OFDM modulation and uses the CSMA-CA protocol in their MAC layer. This protocol has two main advantages. First one is there is no base station is required and point-to-point communication is supported. And the second one is the protocol structure is simple and has low latency, which is suitable for secure information broadcasting. But it also has some limitation. It has weak anti-interfaceability, and the channel congestion is prone to high traffic density, like the highway and the tunnels. In the highway environment, cars may fail to receive the message. Also, the range is limited, generally smaller than the 300 meters. The QoS and the reliable schedule are not supported also. And next is the LTE V2X, also called the 5G NR V2X, which is a comprehensive communication technology that combines cellular network capabilities with the vertical direct communication capabilities. It has two interfaces, the UU interface and the PC-PHY interface. For UU interface, the vertical communicates with the Q network through the base station, suitable for V2N and the remote control. And the PC-PHY interface is direct communication between vehicles, suitable for the V2V, V2I, and V2P, and doesn't rely on the base station. Then, here we list the key data requirements in the protocol. For this protocol, it has several advantages first. Because it relies on the cellular infrastructure, it has wide air coverage capabilities. Second, its strong QoS guarantee machine is suitable for diversified service, such as the in-vehicle entertainment and the remote control. And the last one is it's forward compatible with the new 5G NR-V2X and has a good evolution, which can improve the communication performance. Here is a comparison of the main difference between the two protocols. The main differences are network dependencies, communication range, and the interface and the reliability. The IEEE 802.11p is good to use in a small and dynamic range, while the LT1 is better in a huge situation. In order to realize a perfect communication environment, these two protocols always use together and complement with each other. Another thing worth noting here is that the updatability. The LTE V2X is very important to ensure that it can be used all the time, and with the development of the new technology, it still can be used. Next, let's move to the detailed explanation of the physical layer technology. First, let's have a look at the frequency band selection and the channel characteristics. As described in the previous chapter on the two protocols, the 5.9 GHz HZ ITS band is currently the V2V communication dedicated spectrum that is widely used worldwide. In terms of channel characteristics, considering the particularity of the vertical communication traditional wireless communication is very simple. As we can imagine the scenario is there are many cars drive in different directions with different speed. It's very hard for us to simulate. Due to the high-speed motion of the vehicle, there is a significant Doppler effect in the V2V channel, which will affect the carrier's synchronization and demodulation performance. and in complex environments such as the cities, streets, tunnels, and the highways, channels exhibit significant multiplies effects, which may need to intercode interface. At the same time, due to the rapid changes in channel condition, channel estimate and the equalization technologies need to have the real-time performance, which is also a big challenge. Now, it's time to introduce the modulation method. As mentioned earlier, the two protocols mainly use the OFDM modulation, but through searching, we find that with the development of the 6G technology, there are many studies that propose to use the OTFS modulation method in high-speed communication environments. So here we will give a brief introduction to OFDM and OTFS and point out a main reason for OTFS is better than OFDM. Since we have learned the OFDM in the previous lecture, there we just briefly introduce the method. The key idea of OFDM technology is to divide a wide frequency carrier into the multiple cordial subcarriers with small bandwidths, and use these cordial subcarriers to transmit and receive signals. By doing this, the signals will be like the left figure. When a signal reaches its max, others are all zero, which is better for us to classify. And the right figure shows out the whole process for the communication. Because the bandwidth of each subcarrier is less than the channel bandwidth, OFDM can effectively overcome frequency select fading and be more efficient. And then we turn to the OTFS. For OTFS, there are 5 main steps and we give the main formulas for it. At first, the system maps the modulated symbol, always the QPST, K at the QAM to the delayed Doppler domain grid, also called the DD domain. Then, the discrete symbol side of the DD domain is mapped into the TF domain, the time frequency domain, through the ISFFT. And then, for the Heisenberg transformation, it is turns the discrete symbols into a continuous signal for the transmit and receive. After receiving the signal, it do the demodulation. Use the Wigner transformation to make it discrete signal and use the SFFT to map the time frequency domain signal to the delayed Doppler domain. In short, it is to transmit and connect signal in the time delayed Doppler domain and channel transmission in the time frequency domain. Except for the 2 end steps, the other intermediate steps are similar to the OFDM one. Now, there we will describe a point for the OTFS is better than the OFDM in our understand. If we substitute the formula into the calculation without considering channel noise, we can get that the received signal is periodical extension of the transmitted signal. We can find that after the OFDM signal passes through the linear time varying channels, the signal not only in delayed domain be expanded, but also expanded in the Doppler domain. Taking advantage of the sparsity of channels, the estimated channel overhead of OTFS is smaller than that of the OFDM. OTFS will be more efficient and anti-interface. That's why OTFS may take place of OFDM in the future. Then my partner will give you some application examples.
Okay, there are many applications of V2V in our daily and future lives. Today, I will introduce 3 main applications among them. They are respectively related to traffic safety, pollutant management, and intelligent transportation. V2V can be used in assisted driving system to ensure the traffic safety. The typical scenarios are FCW and BSW. FCW is forward collision warning, which means vehicles monitor the obstacle in front of them and warn the driver and other vehicles of a possible collision. Similarly, BSW is blind spot warning. Sensors will monitor other vehicles in the blind spot and warns when changing lanes to avoid a collision. V2V also plays an important role in pollutant management. Due to V2V communication, the following vehicles can react instantaneously after the lead one sending signals, and the close distance will effectively reduce air resistance and greatly reduce fuel consumption. The third important application of V2V is intelligent transportation. It can help the department predict possible congestion and optimize the signal timing, especially for special cases like ambulances. All in all, the development of V2V can be summarized as social and economic significance. At the society level, V2V communication improves road safety by reducing traffic accidents. This also means accelerating the construction of intelligent transportation system, and just like ITS. At the same time, optimization driving efficiency also reduces energy consumption and emissions, which promotes sustainable society development. From an economic point of view, B2B communication can drive economic growth and reduce energy consumption by improving transportation efficiency. By facilitating the development of related technologies, it can also bring long-term economic benefits to the autonomous driving industries. Of course, the current V2V communication technology still faces many challenges. At the technical level, problems such as compatibility, signal latency still cannot be solved efficiently. Meanwhile, the security and the privacy of driving data is also one of the key issues for the large-scale promotion of V2V. If in the future V2V technology want to be truly applied, relevant laws should be established to ensure the rights of all parties without any delay. In the future, more advanced communication technologies such as 5G and 6G and artificial intelligence will be applied to V2V communication. This will undoubtedly push the autonomous driving technology to the 4L or even 5L stage. The related technology industrial ecosystem will also develop rapidly, rely on the huge market potential. All in all, V2V will undoubtedly become a promising technology and greatly change our life in the future. That's all, and thanks a lot for your attention.